Let's talk about solving inequalities with rational functions or that involve rational functions. Remember, anytime we solve an inequality, we're looking for a whole range of values that will work. So we use interval notation to show that solution set for these. So let's talk about the steps. If we want to solve an inequality, you have to move everything to one side of the equation. So I'm going to move everything to the left on these so that we get some function on the left and then we're going to get 0 on the right. Now we're either going to have a greater than, less than, greater than or equal to, or less than or equal to equation to inequality to solve. If we need to, we're going to get common denominators just to simplify what's going on the left. Now, what we're going to do is set that top equal to 0 and the bottom equal to 0. When we set the numerator equal to 0, we're finding x-intercepts. When we set that denominator equal to 0, we're finding where there are vertical asymptotes. So both places will take this x-axis and it will kind of divide it into pieces. And that's what we're looking for here. So we're going to have some x-intercepts and we're going to have vertical asymptotes. And what we want to do then is we want to test each of those intervals. And we're looking for where is the graph positive if it's above 0, or where is it negative if it's below 0. And then the equal to means we may need to include endpoints. So I like to do this with what's called a sign chart. So let's look at a few examples here. The first one is a picture. A is asking us, where is f of x less than 0? So we are looking for negative y values. Remember that f of x is just a fancy way of saying y. So we have negative y values on this piece of the graph. And that's going from negative 1 up to 0. And then we have negative y values over here, which goes from 1 to infinity. So then our solution would be those pieces. B has changed the problem just a little bit. Now we want to know where f of x is greater than or equal to 0. So now we want y to be positive, or it could potentially be 0. So if we're looking for positive y values, that's happening here, which is from negative infinity out to this vertical asymptote of negative 1. And then it's happening here. Is equal to 0 here, which is an x-intercept, all the way up. So from 0 up to this x value of 1. So there's our answer for that. Now we're not going to include that 1 because that 1 is actually a vertical asymptote for this graph. So we're going to get really close to that, but we're never going to reach that 1. Let's look at the next one. Next one's a little bit more interesting. We have x plus 1 over x minus 1 is greater than 0. We want to solve this inequality. So let's set that top equal to 0. If we set this equal to 0, we're going to get negative 1. So this is actually an x-intercept for this graph. If we set that denominator equal to 0, then we're going to get x is equal to 1. This is a vertical asymptote for the graph. So both of these are places where the graph is going to split. So we have negative 1, that's an x-intercept. Positive 1 is a vertical asymptote. And I'm just going to write VA over this so I know I can't include that number if this were an equal to problem, because I know it's undefined there. So now we're going to plug numbers in. Let's pick something in this interval from negative infinity, between negative infinity and negative 1. So I'm going to use negative 2. And we're going to plug negative 2 in for these x values. All we really care about is the sign. So we're going to have a negative 1 in the top, a negative 3 in the bottom. A negative divided by a negative is a positive. So what that means is that this graph is above the x-axis on that interval. Now let's pick something between these numbers. And 0 is a nice one to pick. If we plug 0 in, we're going to get 1 over negative 1, which is a negative 1. So this guy's negative. And then if we pick something bigger than 1, like 2, remember it's going in for this x here and here. So we have 2 plus 1 over 2 minus 1. That's 3 over 1, and that guy's positive. Now, we want greater than 0. Greater than means positive numbers. So our answer here would be this interval and this interval. So we're going from negative infinity to negative 1. And we're going to use parentheses because it's strictly greater than. And then we're going from 1 to infinity. So there's our final answer. Let's look at that next one, 36. If we set that numerator equal to 0, we're going to have two x-intercepts. We're going to have x is equal to 3 and x is equal to negative 2. So part of this graph could live above the x-axis and part below the x-axis based on those x-intercepts. Now if we set that bottom equal to 0, we're going to get 1 again. That guy's a vertical asymptote. Let's look at this number line. This line is being split by the x-intercepts and the vertical asymptote. So here's negative 2, here's 1, here's 3. And 1 is a vertical asymptote, so I'm going to put VA there. So let's pick numbers in these intervals. We're picking test numbers. So let's pick a negative 3. That's going to be in this piece. It's going to go into the x's here. So we're going to have negative 3 minus 3, negative 3 plus 2 over negative 3 minus 1. So that's going to be negative 6 times negative 1 over negative 4. So that's a positive 6 in the top. Negative 4 in the bottom. Positive divided by negative is a negative. So this guy's negative there. Now let's pick something between these like 0. If we plug 0 in, we have 0 minus 3 times 0 plus 2 over 0 minus 1. So that's negative 3 times 2 over negative 1. So we have a negative divided by a negative, which is a positive. Now let's pick something between here, like 2. So 2 minus 3 over times 2 plus 2 over 2 minus 1. So negative 1 times 4 over a positive 1. So this is a negative over a positive, which is a negative. And then let's pick something in that last interval, like 4. So 4 minus 3 over 4 plus 2, or times 4 plus 2 over 4 minus 1. So 1 times 6 over 3. Positive divided by a positive is going to be a positive. Now we want less than or equal to 0. That's happening here and it's happening here. So our answer will go from negative infinity up to -2. -2 was an x-intercept. It's okay to be 0 here because of that less than or equal to. So we're going to use a bracket. This piece, 1 was a vertical asymptote. We cannot reach a vertical asymptote. So we're going to use a parentheses there, but 3 will have a bracket on it. So there's our final answer for that one. Let's do the next one, 39. So we have x plus 4 over x minus 2 is less than or equal to 1. So this one has pieces on both sides of the equation. We really need 0 on that right hand side. So I'm going to move that 1 over. And then I need that common denominator. Which is x minus 2. So we're going to have x minus 4. And I'm going to distribute that negative. Minus x plus 2 over x minus 2. So we're going to have -2 over x minus 2. You'll always have to simplify these as much as possible before you start using the technique. So this original inequality is equivalent to this inequality, and this one's going to be much easier to deal with. So now we do the process. This one does not have any x-intercepts. If we set that numerator equal to 0, there's no x to solve for there. So no x-intercepts, but we do have a vertical asymptote, and that's going to happen when we set the bottom equal to 0. So we're going to get 2 for that vertical asymptote. So that's the number that separates the sign chart into pieces. And remember, this guy's a vertical asymptote, so we can't include it. So now we need to test to the left and to the right. And it's going to go into this guy. If we plug 0 in, since 0 is on the left, we'll have -2 over 0 minus 2. So that's -2 over -2, which is a positive 1. If we plug in 3, we're going to have -2 over 3 minus 2, which is a -2 over 1, which is a negative. We want less than, so we want this piece. So our answer will go from 2 to infinity. We cannot include the 2 because 2 is a vertical asymptote, so this function's not defined there. Let's look at 44. This one's going to work pretty much the same way. So you may want to pause the video and try this one and then compare your answer with what we get. We want to move everything to one side. And we need that common denominator. So I'm going to multiply that first fraction by x plus 1. And I'm going to multiply that second fraction by x minus 3. And then at that point, I already have that common denominator. So I'm going to put these together, doing 2 steps in one there. Now we need to simplify this. So I'm going to distribute in the top. So we have 2x plus 14 over x minus 3, x plus 1. This guy does not reduce any further. I'm going to leave it. So x-intercepts, if we set that top equal to 0, we're going to get negative 7. We would move the 14 over and divide by 2. We're going to have two vertical asymptotes here, where x minus 3 is equal to 0 and where x plus 1 is equal to 0. So it's going to happen at 3 and negative 1. All of these numbers have to go on the sign chart. So negative 7, negative 1, and 3. 3 is a vertical asymptote. Negative 1 is a vertical asymptote. So I'm labeling those. So now we have 1, 2, 3, 4 sections to test. So let's plug in negative 8. Remember, we're going into this guy. So 2 times negative 8 plus 14 over negative 8 minus 3, negative 8 plus 1. So negative 16 plus 14 over negative 11 times negative 7. So negative 2. So negative in the top. Negative times a negative would be a positive in the bottom. This guy's going to be negative. Now let's pick something in here. I'm going to use negative 2. So 2 times negative 2 plus 14. Negative 2 minus 3 times negative 2 plus 1. Negative 4 plus 14 over negative 5 times a negative 1. So we're going to have 10 in the top, 5 in the bottom. Positive divided by a positive is a positive. Let's pick something in here. I'm going to use 0. We plug 0 into this equation. Two times 0 plus 14 is 14. This is going to be a negative 3 times a 1. So we have a positive divided by a negative, which is a negative. And then if we pick 4 to be in that last section, 2 times 4 plus 14 over 4 minus 3 times 4 plus 1. So that's going to be a positive in the top. Positive times a positive in the bottom, which is a positive. Now we want to know where is it greater than. Greater than is happening here, and it's happening here. So then our final answer would be negative 7 to negative 1, and then 3 to infinity. Now we can also use this idea to help us find domain for different problems. So let's look at one or two of these. 71 is asking us to find the domain for f of x equals the square root of x minus 2 over x plus 4. So we need to know where that radicand, which is the stuff under the radical, is greater than or equal to 0. So let's look at x-intercepts. If we set the top equal to 0, we're going to get 2. If we set the bottom equal to 0, we're going to get negative 4, which is a vertical asymptote. So here's negative 4, here's 2. Let's test. If we plug in negative 5 in here, negative 5 minus 2 on the top, negative 5 plus 4 in the bottom. So negative divided by a negative is a positive. Now remember, this guy is a vertical asymptote, so I'm going to write that in so I don't forget it. Let's pick 0. 0 minus 2 over 0 plus 4. So we're going to have a negative divided by a positive, which is a negative. And then if we pick 3 in that last region, 3 minus 2 over 3 plus 4, positive divided by a positive, which is a positive. So our domain is interesting here. It's going to be this piece and this piece. So it's going to be from negative infinity to negative 4. We have to use a parentheses at negative 4 because it's a vertical asymptote. But then we're going to include the 2 because that's the next intercept. We're going to go to infinity. So there's your final answer. And we can approach 72 the same way. I would encourage you to try this one on your own. Pause the video and see what you get, and we'll compare in the end. So we're going to set that radicand greater than or equal to 0. X-intercepts happen when the top's equal to 0. So that's going to be x equals 1. Vertical asymptotes are where the bottom equals to 0. That's going to be at negative 4. Sign chart. Negative 4 is a vertical asymptote. 1 is an x-intercept. So let's test. If we plug in negative 5, negative 5 minus 1 on the top, negative 5 plus 4 on the bottom. Negative divided by negative is a positive. Plug in 0. 0 minus 1 over 0 plus 4. So we have a negative divided by a positive, which is a negative. And if we substitute in something like 2 in that last region, positive divided by a positive is a positive. So then our domain would be negative infinity to negative 4. We cannot include the negative 4 because it's a vertical asymptote. And then 1 to infinity. Final answer.